Hello everyone, and welcome to the fifth and final section of Chapter 13, Respirations, entitled Supplemental Oxygen. Alright, let's get started here. When administered to a patient, oxygen is considered a medication. An oxygen delivery system is used to deliver oxygen from an oxygen cylinder to the patient. An oxygen delivery system consists of an oxygen cylinder, otherwise known as an oxygen tank, a cylinder valve, pressure regulator, flow meter, oxygen delivery tubing, connection tubing to carry oxygen to the patient's face, and an oxygen mask or cannula to deliver oxygen to the patient. Oxygen is stored in a steel or aluminum cylinder, again, otherwise known as a tank. Oxygen cylinders, they may also be called bottles. May be green, or they may be silver or chrome, with green around the valve stem. Despite their characteristic color, it is best to identify the contents of the cylinder by checking its label or tag. Letters are used to identify the size of an oxygen cylinder. D and E O2 cylinders are small, portable, and often used by EMTs. They weigh between 10 and 17 pounds when full. Onboard oxygen refers to the large oxygen cylinders, H and M O2 cylinders, which are carried on an ambulance. Medical oxygen cylinders sold in the United States will accept a regulator designed only for use with oxygen. In this way, gases such as acetylene, nitrogen, or helium cannot be used with medical oxygen regulator. There are two types of cylinder valves available in the United States. Small, portable cylinders, D and E cylinders, for example, use a pin index valve. Large, non-portable cylinders, H's and M's, use a thread index valve. The amount of oxygen you can get from a cylinder in liters can be found over here in this chart. Portable cylinders hold somewhere between 300 and 700, can put out anywhere between 300 and 700 liters, depending on their size. If it's a D, it's around 350 liters. If it's an E, it can put out around 625 liters. For onboard, an M can put out 3,450, a G can put out 5,300, and an H can put out 6,900. This is important when considering how long you plan on putting your patient on oxygen. For example, if you've got a patient on oxygen, 15 liters, non-rebreather, and you go for, say, 25 minutes, will your D tank allow that? Exactly. It will not. Oops, sorry, I was clicking the wrong button there. When we're using oxygen, it's important to be safe. We never use combustible materials around oxygen equipment. Never place oxygen cylinder where it may become part of an electrical circuit. Never use oil, grease, or other petroleum-based products on oxygen equipment. Never use adhesive tape or a similar material to seal connections or repair leaks. Never allow smoking around oxygen equipment, and this will become a big problem when you encounter patients who actually smoke with their oxygen. Never use oxygen around an open flame. Never store oxygen cylinders in areas of extreme temperature. Never position any part of your body in front of or behind the oxygen cylinder's valve. Never leave an oxygen cylinder unattended. Never drag, roll, slide, or drop an oxygen cylinder. Never lift an oxygen cylinder by its cap. The sole purpose of the cap is to protect the valve. Never carry an oxygen cylinder by its attached regulator. Always store oxygen cylinders in well-ventilated areas. Always secure an oxygen cylinder when moving a patient. Always secure cylinders upright to keep them from falling or being knocked over. Always store full or empty cylinders separately. Use a first in, last out system to prevent storing full cylinders for long periods of time. Always crack cylinder valves open. That's just opening the valve just to allow very little bit to escape, to expel foreign matter from the outlet port of the valve. Always follow the regulator manufacturer's instructions for attaching the regulator to an oxygen cylinder, and always use sealing gaskets specified by the regulator manufacturer. Alright. Pressure regulators. The tank pressure of a fully pressurized cylinder is approximately 2,000 pounds per square inch, but tank pressure varies with temperature. Tank pressure is increased with increased temperatures and decreased with decreased temperatures. Because 2,000 psi is too high a pressure to be delivered to a patient, a pressure regulator is used to release oxygen from the oxygen cylinder in a controlled manner. It reduces pressure in the oxygen cylinder to a safe range, about 40 to 70 psi. Regulators may decrease the cylinder pressure in one or two stages. A one-stage, or called a single-stage regulator, decreases the cylinder pressure to a preset working pressure of about 40 to 70 psi. A two-stage, or a double-stage regulator, creates two steps in the pressure drop. The pressure is first decreased as the gas leaves the cylinder and enters the regulator. It is reduced again when it meets the liter flow gauge. Next, we're going to go to flow meters. A flow meter is a valve that controls the liters of oxygen delivered per minute. Oxygen flow is measured in liters per minute. The range of the flow meter is usually from 0 to 25 liters. It may occasionally be 0 to 15 liters. Back to the pressure. The minimum tank pressure for any oxygen tank on a Kentucky licensed ambulance is 500. If you are being inspected, you have to have at least 500 psi in every single oxygen tank. Alright. Let's get to setting up an oxygen delivery system. Step 1. Place the cylinder in an upright position and position yourself to the side of the cylinder. Verify the contents of the cylinder by checking the label or tag. After making sure that it is an oxygen cylinder, remove the protective seal covering the inlet. Step 2. Check the regulator and oxygen valve to make sure they are in good operating condition and free of dust and debris, such as oil and grease. Make sure that a washer or gasket is in place at the opening of the oxygen cylinder or regulator. Alright, step 3. After making sure the cylinder valve is aimed away from people or objects, quickly crack, again, open then close it immediately, the main valve of the top cylinder to blow out any dust or debris from its opening that might cause the valve to stick. You may need to use an oxygen wrench to open the valve, then close the valve. Step 4. Attach the pressure regulator to the cylinder. Carefully line up the pins on the regulator with the holes in the cylinder valve. Use an appropriate washer or a gasket between the regulator and cylinder valves to ensure an airtight fit. Step 5. Hand tighten the clamp of the regulator. You don't want to make it too tight because it'll make it difficult to come off, but if you don't have it tight enough, then you'll have air leaking out around the regulator. Step 6. Open the cylinder valve by turning it counterclockwise. Check the pressure in the cylinder and listen for leaks. If you hear a leak, close the valve. Verify the regulator is properly attached and the washer or gasket is properly placed and in good condition. Then repeat step 5 and 6. Step 7. Attach the oxygen delivery device to the regulator. Adjust the liter flow to the desired setting by turning the appropriate valve or knob on the regulator. Step 8. Apply the oxygen delivery device to the patient, securing the oxygen cylinder, whether that's a manual breather or a nasal cannula. Alright, when we're discontinuing an oxygen delivery system, step 1, we remove the oxygen delivery device from the patient, turn off the flow of oxygen. Oops, sorry about that. Step 2, we'll turn off clockwise the main valve on the top of the cylinder. Step 3, bleed oxygen out of the system by opening the flow meter valve until the flow stops. Close the flow meter valve. Step 4, if the cylinder is empty, loosen the clamp and remove the regulator from the cylinder. Store the oxygen cylinder appropriately, according to manufacturer's recommendations and SOPs. Next, we are on to oxygen humidifier. Medical oxygen is very drying to airway and lung tissues. A humidifier is a bottle filled with sterile water or distilled water. When the bottle is connected to oxygen, oxygen passes through the water to gather moisture. In some EMS systems, humidified oxygen is used when caring for patients with smoke inhalation, children with certain respiratory conditions, and during long transports when a humidifier is used. During long transports. When a humidifier is used, it should be changed after each use to prevent the growth of bacteria in the container. Some are single pre-filled units. Some are empty units that you have to open and utilize a bottle of sterile water.